So welcome again, guys, and congratulations for your selection round 3. So now Roshni will explain you about round 3. Okay, Roshni can take over.
Yeah, so hello everyone again. So round three basically is nothing but we will be giving you a document having all the problem statements. You need to choose your problem statement and work on it. You need to prepare a working circuit solving the problem, and also you need to present it to the speaker who will be judging you. The presentation time would be only 10 minutes, and you will be having 30 minutes to solve the problem, and you will have 30 minutes for your preparation for the presentation. You can maybe distribute however you want. We are not restricting you to make the 30 minutes only for making circuit or 30 minutes for PPT. So in total you have 1 hour. You can work on it however you want. So now I will be posting you the document having the problem statements. There is a restriction. No two teams or two individuals should be choosing a single problem statement. For example, if Abhay is choosing problem statement 1 and Kural is choosing problem statement 1, the problem statement 1 is locked. Uh, the third person cannot take the problem statement 1. So that is the use case. So you have around 10 to 15 minutes to choose your problem statements. Please post them in the chat box or inform by unmuting yourself so that we will log the problem statement accordingly. I'm posting you the document having the problem statements right now in the G chart. If any doubts, please ask me out. That's it. That's it for the round 3. You will be only having 10 minutes for the presentation, so please restrict it accordingly. I hope the problem statement document is visible for everyone.
So everyone has understood, right? You can see on the screen as well. If any doubt. Okay, so Akshay 6th. Okay. So whatever you choose is write it over here so that we take a note of it. Okay. Sayed 1.
Arushi, can you update that in the sheet?
Yeah, I'll update. Share me the.
Like log that, you can log that, right? To keep updated.
Mhm.
Yeah.
Okay, so Akshay, Sayed, Lalit, Sayantan, Abhay, and Lisa have decided. Others decide and update me.
When we have to start.
Let everyone decide. Okay, then you can start.
Okay.
Okay.
Is number 10 taken? Like, what is it?
It is.
Is it? I didn't hear you properly.
Yes, it's taken.
Okay.
Hello, am I audible?
Yes, Rohan, you are audible.
Yeah, actually, I wanted to take the number 9, actually. Problem statement number 9.
Okay, sure, noted.
Okay, so should
It's
I
taken. One Lalit has taken it.
number 9th?
Yeah, number 9.
Okay, then going with the number 8.
Okay. Just write it in the chat box.
Yeah, for sure.
Wait, so I can actually do 10, or because there is only one other person mentioning 10 in chat.
Yes, Guru, you can.
I already taken number 10.
Okay, I'll take 10.
I hope everyone decided their problem statement. Is there anyone left?
Is number 9 is taken by 2 guys, or just with a single person has taken the number 9th?
Two guys have taken, like, we have informed one for one problem statement, two individuals or two teams can work.
Like,
More
Lalit
than
has already taken, right? So another person haven't taken yet. So
If
I
you
can take.
can, you can take it, Rohan.
Okay, I will take 9 then. Okay, let's mention it 9.
Could you repeat the deadlines for this round?
Sorry?
Could you repeat the deadline for this round?
Deadline.
Yeah, by when do we have to finish this?
Yeah, I will give you the introduction. Okay. So everyone has decided, right? Koral and Rupak, you both have taken 10, right?
Yeah, I'll
Okay.
choose first.
Yeah. Wait, so one person, one topic is only for one person, or like you said, two people can take one topic, right?
One topic, two people.
Okay, yeah.
I think we can begin the.
Roshni.
yeah, sure. So you can start working because there are no teams, right? Everybody is working individually. Am I right?
Yeah.
Okay. So if we are working in team, we will prepare a breakout. room for you. If it's individual, you can start working.
And randomly, we'll ask you to screen share your uh, project sheet.
Yeah,
So-
judges will arrive at 7 p.m. So they can ask you to screen share. And you have to also prepare the PPT for it.
And also in the progress, also you need to screen share your
Yeah, when you will present in front of the judges, right? So you have to prepare the PPT and you have to present the circuit as well, circuit design as well. You'll get 1.5 hours to complete your work. So you can begin now.
1.5 hours starting when?
Starting now, 6:20.
So around 8:30, I think.
Yeah,
No, it's 7:30 would be the
7:30.
presentation.
Yes.
Okay.
Okay. So all the best, everyone. Rocket.
Hey, can I log out and go to Shutter Safari and finish it and come back like to this meet?
Yeah, you can if you can manage your time and
Yeah,
work.
I don't have an option.
Okay, okay, you can. Also, you can work on any tool, not specifically Tinkercad. Okay.
Uh, Hi Jashwita. So quick intro about round three. So we have posted a document. I'll post it again, which will have the problem statements, and you need to work on any particular problem statement, solve it, and build a working circuit. And also simultaneously, you need to prepare a presentation about how you solved it and how innovative is your solution. So what happened was people have chosen some of the problem statements. So only two individuals or two teams would work on one problem statement. So pick your problem statement accordingly. I'll post you who all took what problem statements as well, so that you will not clash out. The document I have posted it again, and I'm posting you who took which problem statement as well. So for now, the problem statement 9 and 10 is blocked because more than two people have been selected it. Rather than it, you can select any of the problem statements. Yeah. All the best. You have total 1 hour to prepare a working circuit and presentation, and you will be given 10 minutes to present it in front of the judge.
Hello, did the round 3 started? I have just joined.
Yes, Dipanjan. Actually, the round three has been started, but I'll give you a quick intro. So in round three, we will be having a document containing all the problem statements, where you need to select the problem statement which you want to work on and build a working circuit solving it. And then you need to also prepare a presentation where you need to indicate how you have solved it, what are innovative things have you discovered while building the working circuit, and all those things. And for selecting the problem statement, there is a criteria. No two individuals or two teams can select one problem statement. Like more than two people cannot select one problem statement. So four people, like ninth problem statement and 10th problem statement, is blocked as of now. I'll post you the document. You can see and choose which problem statement you want to work on, and just please inform it in the G chat, so that if you're working on any of the problem statement chosen by the participants, we will block it.
Okay. Am I too late?
uh, we started at 6:15, so 15 minutes late.
Okay.
Please inform the problem statement which you're choosing in the GChat, okay?
Hello.
Yes, Rupak.
Color sensor is not available on Tinkerpad, so
Yeah,
how can
you are
I?
free to use any of the tools you want. Like it is not any restriction. Like you only need to stick on Tinkercad.
Okay, but I don't know how to use another tools.
Oh.
Okay, I'll
So
try using.
you can try using another components.
I have a question like if I use any extra inputs sensor, so does it be valid?
Yeah, it's valid and it will be also considered as a bonus.
Okay, okay. I have another question. Uh, I have chosen space habitat environmental control. Uh, in the input simulation, it is written that multiple potentiometer stands in for O2, CO2, humidity, and temperature. So, do I have to use the gas sensor for the input, or can I just use the potentiometer just labeled as the gas sensor name?
For reference purpose only, we have attached in the document. You choose whatever is suitable for you and you think is best possible innovation. So it's
Okay,
it
so I
depends
have
on you. You
the
need not to stick on the input given in the
okay, okay,
document.
okay,
Yeah.
okay, okay.
Swadesh,
Yes, ma'am.
you joined late, so are you working on the circuit right now?
No, ma'am. I just joined because of my some work.
Okay, so will you
Can you
participate?
explain, please? Yes,
Yeah,
yes.
sure. Roshni? Or okay, so we'll provide you a Google Doc link. Okay, there are problem statements. Roshni.
Yeah, yeah. So Swadesh, we will give you a document having all the problem statements. You need to select which problem statement you want to work on. And okay, is my voice clear, right?
Yes, yeah, this is
Okay.
clear.
Okay, so we will give you a document where all the problem statements are there. We have striked off the problem statements which are blocked because the meeting started at 6:15. So you can choose the problem statements which are not striked and work on them. And you are running out of time. Like we have given 1 hour to them, like till 7:30. So try it and choose your problem statement and note down which problem statement are you going to work in the G chart. And also, you need to prepare a presentation which you will be presenting in front of the judges for 10 minutes. The
Okay,
Yeah,
till 7:30, I have to make the solution and also the presentation.
exactly.
Okay, ma'am. Can you share the link of the problem statement
Yeah,
again?
yeah. 1 minute. Just choose your problem statement and mention it in the G chat so that we will get it.
Hello, guys. Rahul, can you screen share your work?
Yeah, me?
Yeah, it's you.
Okay.
Syed, PPD making depends on you. Whatever you want to add in it. Okay.
Is it visible?
Yes, it's visible. Keep your microphone.
Rahul, you can stop the presentation. Okay.
Nice, Rahul.
Guys, I have a doubt.
Yes, go ahead.
Yeah, so since Tinkercad does not have color sensor, can I just assign 3 buttons to simulate colors?
Sorry. Yeah, also, you can use another tool if you want to use other than Tinkercad. Okay.
Like other simulation platforms.
Yeah, yeah, you can do it.
Okay, that's time consuming. Okay, okay, sure. Thank you.
Syed, can you screen share your working
Yeah, one
sheet?
minute. Yeah.
Yeah.
Is it visible? Hello.
Yes, it is visible.
Okay. Okay.
Guys, I can use walk-free, right?
Yes, Kunal, you can use. You just have to present the screen in front of the judge and make the PPT, okay? You do accordingly. And you all have only half an hour left, so please be on time.
Sayed, you can stop screen sharing.
Okay, thank you.
Okay, thank you so much.
Lisa,
Lily,
can you please?
can you screen share your project?
Okay, so I have only a half an hour left.
Or Lisa, can you screen share your working sheet?
Okay, wait, let me join from the PC. Actually, I have joined the meet from my mobile phone.
Okay, okay, sure. Tanuj, can you screen share your working project? Rupak.
Yeah, on me.
Yeah. Hello, Lisa. What's your problem?
I'm just trying to connect it from my PC. Sorry,
Okay.
just 2 minutes.
Okay. No, no, no. You can screen share after Rupak's. Rupak, it's better to screen share the only one window. Like you don't need to screen share the entire screen. Or Lisa, can you screen share it now?
Yes, yes.
Yeah. Okay. Do that.
Is this okay?
Okay. Okay, Rupak. That's fine, Rupak. You can stop screen sharing. Lisa, can you screen share it now? Or Tanuj? Abhay Krishnan, if possible, can you screen share your project?
Are you able to see?
Uh, Lisa, instead of sharing your entire window, you can just screen share the working sheet or working window. Okay, fine. You can continue like this.
Hello. Hello. Hello.
Okay, Lisa, it's enough. You can stop screen sharing.
Hey, can I change my topic to 11?
It's up
I
to your
think,
choice, but so you have only 30 minutes left.
yeah, I can't do the color sensor thing.
Okay, it's up to
It's a
your
lot of
choice.
work. Yeah,
You can switch that.
Same
thank you,
thing.
thank you.
I'll fetch.
Okay, if you want, you can change, but make sure to complete it fast with the PPT and everything, okay?
Hello. Can anyone hear me?
Yeah, now you are audible, Tanuj.
Hello. Sorry for interrupting. I just want to ask if I was called earlier for screen share. I was presenting my final presentation for CIA right now. It just got over now.
Yeah, it's okay.
Tanuj, you can stop screen sharing. Abhay, can you screen share your working sheet?
Yeah, sure.
Yeah. Abhay, can you screen share your working sheet? Or
I was screen sharing.
okay. Oh, okay. Sorry, sorry. I can't see.
Okay, Rupak, you can change. Make sure you have only 20 minutes left.
Abhay, I can't see your screen.
It shows it's screen sharing. Can you tell me what you're saying right now?
I mean, can you? I am asking you to screen share your working sheet. But I can't.
This is it. Am I screen sharing something? Wait, I'll just restart the screen share.
Okay. Jeshwita, can you screen share your screen?
Yeah, I am sharing right now. Is it
Oh, okay.
visible?
Now it is
Okay.
nice.
Okay, Abhay, you can stop the screen share. Thank you.
Jeshwita, can you screen share?
I'm
Or Deepanjan?
Yes, yes, yes. Does my skin visible?
Yes, yes, your screen is visible.
Okay.
Okay, the Panjan, you can stop the screen share. Guys, you have approx 10 minutes left. Be quick. Judges will arrive soon, so please. And make the PPT, okay? You have to present it. And give the description also through your PPT and your circuit, okay? Great, Sayed. Just practice the speech, whatever you will deliver in front of the judges, okay?
Jaswita, can you screen share your working sheet?
Am I audible now?
Yeah, you are audible.
Okay, I'll share my screen. So this is the prosthetic. Am I audible?
Yeah, you are audible.
So wait, I'll start the simulation. Hello?
Yeah, you can work now, Jaswita.
Thank you.
Let's be fast. You have to make the PPT as well. So you're on time, okay?
Jaswita, you can stop screen sharing. Swadesh, can you screen share your working sheet?
So 1 minute, please. I'm working on
Can you
this.
share your
Give me five.
screen? Like, on which circuit are you working on? Can you share it?
Perfect. Right. Okay. Is it visible?
Yes, it is. Okay, okay, you can work now. Just wanted to see. Great, guys. So you have only few minutes left. Be fast, be quick. Prepare the PPT, prepare the speech as well, so that you can present in front of the professors.
Guys, is PPT really necessary? I mean, I'm done with the circuit. I can show it if you want.
Sorry?
I'm done with the circuit
Okay.
right now. So, like, what should be include on the PPT? Because, like, I have really
The
less
description
time.
of your circuit, what have you made, what are you working on, and everything.
Can I use AI self for the PPT?
Depends.
Okay, so that would not be a factor for disqualification, right? I just want to make sure.
That depends on the judges. We don't have anything to say.
Okay, so I'm done with the circuit. If you want, I can present it right now.
No, not right now. Let the judges
Okay,
come. Okay.
yeah, sure.
Prepare the PPT and whatever
Yeah,
you wanna say.
yeah, thank you.
Okay.
Sure.
Are you done, guys? Sayed done. What about others? Nice. So one. Also in the PPT, you have to mention the problem statement you've got. So just add it if you have it. Okay.
Yes, Arushi, sorry, I was on mute. What was the question?
Is there like a specific number of slides that we are supposed to have? Guys.
Yes, cool.
Yeah, so like, is there any specific numbers of slide we have to have in our PPT? Like,
Depends on you. It should be short.
okay. Yeah.
as you will not get more time. Okay?
Yeah. Thank you.
So we have the judges here. So be quick, guys. Are you done with the circuit and PPT, guys? Just give me a thumbs up. So we'll end this at 7:40. Okay. You have only 6 minutes left, so be quick, please. And after that, we'll start with the speaker session. Okay. And be ready with your presentation. We'll call randomly. Time's up, guys. I hope you all have done. Just a thumbs up, everyone, so that we know that you've done. Syed, Lalit. What about others? Sayantan, TK, and others. Rohan, great. Jaswita, Kural. Okay. Prepared with the PPT and all? Syed, Lalit.
Well, I could call that a PPT.
Well, what about others? Rahul and Abhay, Dipanjan, Tanuj, Lisa. Have you all done? Okay, so now we'll randomly call the name. Do it fast, Tanuj. You don't have time.
Ma'am, can I get slight more time? Slight.
What?
Can I get slightly more time? I was actually late 15 minutes.
More time as in have you prepared the circuit? Or
Yes.
so prepare the PPT.
Okay.
Just fast. Okay. So we have one judge here. Other one might be joining in some few minutes. Till then, you can just go through your PPT, prepare your speech and everything. Be ready, guys. All the best, everyone. Okay, Roshni.
Yeah.
Yeah.
So
Okay, so we can start, right?
yeah, would you switch the slide?
Yeah, just a second. So I hope everyone is done with their circuits on PPT. So we have our judges here and would like to introduce both the judges to you. Okay.
Yeah. So today I'm going to give a brief out about Professor Ganeshya Misra. He's a highly respected name in the field of electronics and engineering education. Sir is currently serving as senior faculty at National Institute of Electronics, where he has been mentoring and shaping future engineers with dedication. Professor Mishra holds his BTech, MTech, and PhD from prestigious IIT Kanpur, which itself reflects his deep academic foundation and commitment to excellence. His domain of expertise lies in embedded systems and wheelless side design, two of the most critical area driving innovation in modern electronics, from smart devices and also semiconductor technologies. In short, Professor Ganeshya Mishra is not just a teacher but also a guide and also a teacher who is shaping our future. And we are truly honored to present him as our judge for Circuitrix event. Now we would like to introduce another judge, Arushi. Just
Yeah.
Thank you.
That was a great introduction, everyone. Now we have another judge. It is my honor to introduce our esteemed guest for today. That is Mr. Nikhil Shukla, who is currently serving as a research scientist at Bharat Electronics with expertise in technologies such as LTRA, DDS, and Qt Creator. He has been contributing to impactful technology driven projects that strengthen India's innovation ecosystem. So, Mr. Shukla is also gold medalist, graduate from Madan Mohan Malviya University of Technology, and the founder of the CodeChef Triple MUT chapter, where he inspired countless budding engineers to sharpen their problem solving and coding skills. So, we are truly privileged to have him here with us today to share his experiences and insights. So, kindly welcome both of the esteemed judges over here,
Thank you
everyone.
so much, guys, for the invitation. I'm really glad to be here.
Thank you so. We are also glad that you both are here. Okay, so now we'll begin with the presentation. That is our main motto for today. So we will call out some random names. We have provided you the scoring sheet. Based on the presentation, based on the skills, speaking skills, and based on the circuit design, you will be grading them. So first, Sayed Zainuddin, you can screen share your presentation and begin with it.
Good evening, teachers.
You can screen share, please.
Okay. Hopefully, my screen is visible.
Yeah, it is. Go ahead.
Okay. So, my topic is brain-computer interference that translates simulate brain signal into physical actions. As we all know that our brain uses electrical impulses to communicate to our body organs and body parts. So we just need to amplify that signal in such a way so that we can communicate with our own machines which are made by us. So let me go ahead. So what is a BCI? What is BCI? So it's just like a bridge between our mind and a machine, and we use the electrical impulses so that we can communicate with others, and it is important, and it's a revolutionary potential also, like enhancing the game and virtual reality experience which is booming right now. And also a person with disabilities, like who cannot move, paralyzed. So my goal is to create a demonstrator model so that we can easily understand what is a BCI work. So as you can see, the conceptual model of BCI, it's connect the brain to external devices, translate to it into actions effectively. It facilitates control without physical movements, like we don't have to move, just think about it and the machine will work out. And understand band signal is key for BCI. That's the fourth point is the key point for this. Without this, we cannot work further. And here's my circuit. I will show in a while how it's work. Okay, there is the potentiometer which is acting like a brain, some LEDs, and the Arduino Uno, of course, the computer, which translated and how it works. So the input I take as a potentiometer, which simulates low variable analog signal from the brain. Like turning the knob will changing your mental state, and processed by Arduino Uno, read the raw signal and then code to interpret it. It filters the signal into different state and maps it to create command for movement. For output, I take LEDs and a servo motor, and LEDs I take green and red and yellow also for showing the different state of mental health, and servo motor uh, show that it's relaxed, moving, or extremely working. So the conclusion is our simple model successfully demonstrate the powerful core principle behind this life-changing technology, showing how a thought or interaction can be translated into a physical world. So can I go with the circuit?
Sure, go on.
Yeah. So here's the circuit. So like as you can see, it's right now it's in green, and the knob is zero, set to zero, and servo motor angle is to zero. That means right now I am relaxing, suppose. And when I turn the robe, it just switch to yellow. That means I am doing some work, and the servo motor state the state the knob like how it's working. It's like moderate working, not heavy too much. And when I pull the knob, you can see that the right light blinks and take the 180-degree angle. That means I'm stressed there and working extremely. Brain is putting so much of work. And when I get to my sleep, I will just get to relax mode. So is my full circuit here. So shall I done with this? And thank you for this extremely crazy event, the Circuitrix. And I
Um,
love to join that.
Januddin, I have a question for you.
Yes, sir, please.
Is it scalable for a lot of people? Like, how can you scale this design in real world? And what are the practical application of the circuit you showed me right now?
The practical, like, sir, suppose a person is paralyzed and he can't move, but her brain is, of course, is thinking. So we can turn her brain signal and amplify in such a way that we can use a metal arm or metal leg for her moving.
Okay. If you have got more time, what are the things you have added to this circuit to make it more useful, like to add more features to the circuit? What have you done? If you have got more time.
If I have got more times, I first of all, I of course put a OLED display also, so that you can just instead of LED, I can use the LED display to demonstrate, saw that how the mental state is going.
Okay. Okay. Thank you, Jan.
Thank you so very much.
Januddin, I am audible. Am I audible?
Yes, sir.
Okay.
Yes, sir.
There is one query from my side.
Yes,
The
please.
signal which is generated from potentiometer is finally converted into the digital form by the UNO board. So, which component does this on UNO board?
And can you repeat, sir?
Which component on the UNO board does the conversion of the analog signals comes from the potentiometer?
Sir, is the microprocessor in the UNO board which do that conversion?
Have you heard about analog to digital converters, A to D converters?
Not yet, sir.
Oh, okay. Thank you. Thank you.
Thank you, sir.
Okay, so sir, you can grade them in the scoring sheet, and then we can. Rahul Kumar, you can go ahead now.
Hello, am I audible?
Yeah, you are. Your voice is echoing, so if you are from another device, just disconnect it and go ahead.
Okay.
Yeah. Okay. Screen share and just begin it.
Okay, so the problem statement I had chosen was implantable glucose monitor, which is Arduino-based simulation, and as we know, it's round 3 of Circuitrix, and it is done on Tinkercad. Next is this is problem statement, and my goal was to basically identify the defect, means what is the current glucose level in our body by potentiometer, and to provide visual and text alert to a monitor, or say by turning on a different LEDs color. So the components I used was Arduino Uno and potentiometer, then RGB LED, and then buzzer and breadboard, then registers, which I set to 220 ohm, and Tinkercad software I used. Next is block diagram of my circuit. So this is my circuit where I connected uh, buzzer and LED and then potentiometer to Arduino, and then coded it to work as like when the glucose level is uh, between 0 to 120 mg per L, then it will show red alert and so glucose level is high, and between 120 to uh, 200 it shows it's in borderline, and it shows blue light, and in after 200 mg per L it shows green. So this is the core logic that I told right now. Next is this is the logic that I have used. Glucose level is less than 120, then green. Else if glucose level is less than 140, then blue, and else red LED plus buzzer if it's less than 200. So my simulation works as like when I turn on the potentiometer knob uh, to change glucose level means and then at different levels I observe a different colors on LED. So basically I used RGB LED. So it's in serial monitor it shows uh, safe and borderline and alert for different levels of glucose. This is the test result that I simulate and get in my Tinkercad circuit. Creativity I used was 3-level monitoring, that is safe, borderline, and critical, and it's like heartbeat style budget alert, and then it's wireless, which is simulated via serial monitor, and this it's clear and real life inspired demo. That's it. Hello.
Do you have any questions, sir?
Hello, am I audible?
Yes, yes.
See, both the projects, the previous one and this one is in similar as the components which you people have used is potentiometer, and finally you have shown the result with LED. So how you have decided the range of glucometer with the changes in the resistance of potentiometer? Means how you decide that 70 or 120 glucose level is varying with the changes of resistance in potentiometer?
So sir, basically in Arduino, I map the Arduino like uh, it will show a different LEDs color between 0 to 200 mg per L, and that's potentiometer part. A potentiometer can have variable resistance. So when it detects less than or more than some set resistance, it will show different levels of glucose like that.
Okay, thank you.
Okay.
Hello, Rahul.
Yeah.
Uh, do you had any other approach or any alternative component which you have used for this
Ah,
design?
I was thinking of using LCD for showing high or borderline or safe zone, but for due to lack of time, I did not have used LCD.
Okay.
Okay, thank you, Rahul.
What?
Thank you, Rahul. You can just stop
Okay.
sharing. Yeah.
Okay.
So you can evaluate in the scoring sheet both the result. So then we can start with the other one. Rupak, be prepared. Rupak Kumar.
Sir, I have shared the scoring sheet in the chat
Yeah,
box.
they are doing, Srinath.
Thank you. Thank you.
Rupak Kumar, be prepared. Your turn is next. So Rupak, are you there? Rupak. Okay, so I guess he's not there. We'll go with Akshay.
Okay.
Yeah. Share the screen, Akshay. Go ahead.
Yes. Okay. Are you able to see my screen?
Yeah, it's visible.
Yes. So my problem statement was creating an AI-enabled smart traffic management system. So first of all, the challenges why we require this system, right? The challenges we face is like the traditional traffic management systems are uh, hard coded, right? So they give even timing to all the roads. Suppose the road we are at a cross section, then 5 seconds will be given to a road which is very busy, while the same time will be given to the other road which is not that crowded, right? Also, this kind of system does a lot of emission fuel wastage, right? So that also causes economical loss, and it can't adapt dynamically to the increasing or decreasing traffic loads. So that's a drawback. That's a major drawback we are trying to solve over here. So what is our solution, right? How we are going to cater this problem? As I said, it is AI enabled, and we are also using IoT. The green light adapts to the dynamic changing traffic loads on each roads. So as the traffic density, the load increases, the green light also increases its timing. Real time, it will adapt to the crowd, the load of the roads, and manage accordingly. And also we have ensured that in case the AI fails, in case uh, maybe either of the sensors fails to detect the data stored, or maybe any failure, we can get back to the traditional hard-coded logic, right? So that logic is also incorporated in our solution. So we don't have any drawback. It's just an add-on which we are getting. uh, so a system architecture, how we are going to build it. For now, as I said, for controlling as our brain of our system, we are using Arduino Uno. And for sensor, we are using ultrasonic sensor XCSR4 and a potentiometer, which I will be demonstrating later in the simulation as well. And for interface, we are using RY and red LEDs. So intelligent sensing layer. Here we are actually detecting the main road traffic in real time, instantaneously. We are giving a little bit priority to the main road, while a little less to the cross section road. The main road traffic is detected in real time simultaneously, while uh, what traffic is there at the very instantaneous period, right? While on the cross section perpendicular road, we are getting an overall traffic range. So we first calculate the traffic need, analyze. First, we will get the data from both the sensors, analyze uh, what demand we have on which road, and according to that, we have a formula over here. The final timing given to each of the road, which is a base timing. We have set it right now 5 seconds. A base timing plus what demand we have on the particular road minus the pressure reduction, the pressure on the other road, right? So this ensures that we are dynamically considering both the loads and managing accordingly. And AI integration. So as this is the main part of our system, it will store the historical data. What are the historical trends, and adapt to it accordingly. Like on different time periods of the on different time slots of the day, we have a different traffic density, right? So it will learn from the older data and adapt to it in future. And also environment factors and event intelligence, which we can provide to the AI. And as I earlier said, we had incorporated uh, every possible uh, fail-safe mechanism in it. If either the sensor fails, or uh, the microcontroller fails, any of them, we will get back to the hard-coded logic, and uh, a definite amount of time will be given to each traffic light, and the operation will continue smoothly. So I will now demonstrate the circuit, sorry, simulation. Mm. So yes, are you able to see my simulation?
Yes.
Okay. Okay, so first of all, we are having both the okay. So on the right side, we have our main road, while on the left side we have a perpendicular road, the secondary road, and I'm using ultrasonic sensor to as a sensor to detect the traffic on main road, while a potentiometer as we are taking the instantaneous data from the main road, right? So I'm using an ultrasonic sensor while we are getting an taking an average and overall traffic from the perpendicular, the secondary road. So to simulate that, I'm using a potentiometer, and so as mm, oh, sorry, I mistakenly forgot to connect this wire. So yes, we are all set. So as we started, first the system is initialized. We have 5 seconds, which is minimum time given to both the roads, which is 5 seconds. So first of all, we will demonstrate the perpendicular road. Uh, we will increase the traffic load on perpendicular road while keeping the load on main road as 0. So here we can see its distance for the ultrasonic sensor, the main road density and the perpendicular road density. We have perpendicular road density around 10. So we are giving more time to the perpendicular road while less time to the main road. In a second case, we will reduce the perpendicular road traffic while increasing the main road traffic. So it will adapt, and now it is giving more time to the main road. And just a second, I guess the simulation is lagging a bit. Okay, so we are giving more time to the main road. So if we move on to the third case, which is the main case, right? Our main case when both the roads are having uh, somewhat not maximum, not minimum, somewhere between their loads, then how will our system react? So we will try increasing the secondary road traffic. What basically happens over here is uh, in normal case, uh, when the traffic is lesser on both the roads, a constant time period is given for both the roads, and as soon as we detect even lower traffic on the main road side, we start giving priority to the main road, and as traffic increases on the secondary road, we just subtract or take away some time from the main road's traffic signal. And as the secondary roads traffic increases, we add on to sorry decreases, we add some time to the main roads traffic signal. So that's what basically we are trying to do over here when both the roads are having traffic load simultaneously. When we take this to maximum, So yes, we are getting the minimum time on main road, and 12 seconds on the secondary road. So that's my simulation. And if we see what are the future integrations we could make in this, getting back to the PPT. But we could integrate cloud AI integration. So we can also take the data from other nearby traffic signals as well. Computer vision now, as we are using ultrasonic sensor over there, we could incorporate computer vision as well. And as cloud integration suggests, citywide network, it will also allow us to make a citywide network which will manage the whole citywide traffic and in a dynamic. So yes, that was my presentation. Open to any questions.
Wonderful presentation, Akshay. Can you please explain how are you calculating the demand, the traffic demand?
So yes, as we are having a very low demand on main road, the priority is given to the secondary road. And when we it's done into cases. Okay, so when we have less, almost no demand on first road, the priority is given to secondary. And when we have very less demand on secondary, the priority is given to the main road. When we have simultaneously a load on both the roads, a little bit more priority is given to the main road. What we does is, there's a formula. A final timing will which is given to the main road is like base time, which is 5 seconds, plus demand, what demand we have on the main road, minus the pressure we have on the secondary road. So that's how it is done.
Okay, so now you're using some sensor, but in future when it is deployed in practical applications, the sensor will not work because the range of the sensor is only, I think, in centimeters. So when the camera will be there instead of the sensor, how will the solution will change?
Okay, as soon as we get the camera, we have to implement the ML model over there. So to as camera captures the images, right? So the ML model will identify all the cars in the image and calculate the overall load traffic density we are having. So that's add a load on the server.
Okay. Okay, thank you, Akshay.
Thanks.
Okay, Akshay, I have
Yes.
a question. In the Internet of Things, there are three major areas: data collection, automation, and real-time communication. So,
Yes, sir.
in which area, if you get a chance, you thrives uh, well, such in data collection or in automation or in real-time communication?
Okay, so you are trying to ask in which sector our
You
solution?
prefer you prefer to work. You prefer to work.
Okay, in which sector I prefer to work in?
Yes, either in data collection or automation or real-time communication.
I would love to work in automation.
So, have you any idea that how sensors fuse and the algorithm which is used by the sensor fusions to work with the Arduino or with the major processors?
I didn't get the question, sir.
Okay. What presently you are doing?
Presently, I'm in my second year of BSc in Electronic Systems. Right
Oh.
now, I'm working on just circuit simulations and all.
Okay.
to be more specific on FPGA, right?
So FPGA. So you have done the work on FPGA kits?
Not very much of experience on it, but right now just little bit starting on the language, starting with the architecture of
As
FPGAs.
it is seen in your presentation, you are done a very wonderful job with your presentation and uses adaptive algorithm. So it means that you are inclined towards the building of algorithms more. So it means that you have more inclined towards the coding part in the automation.
Yes, yes, definitely, sir.
Okay, thank you.
Okay, thank you, sir.
Nice, Akshay. That was a great presentation. So we would like to call now Kural.
Okay. Hey guys.
Yeah.
Good evening. So I should start with a PPT, I guess. Yeah. Just a second. So is my screen visible? Hello.
Yes, it is.
Yeah. Okay. So the title I chose was like air quality monitoring with Arduino. Uh, in the problem statement is it was given as this device would be implemented on schools. So the thing is, with the problem statement, what I figured is that it could be easily executed with a logic that compares this input from the sensor with a threshold value. Actually, I was running out of time when I began, so I had to rush it, and this was the only easiest topic I found. So the problem statement is poor air quality in classrooms, and it affects students' health, and so we needed a device for that. Uh, so here I am using potentiometer to simulate an input from carbon dioxide sensor and uh, other air particle sensor. So, and the Arduino here in the circuit compares the value and activates the countermeasure. So the action is, if it's unsafe, ventilation turns on, and if it's safe, ventilation doesn't turn on, and it indicates that the air quality is safe. We are using LEDs to visualize that. So the hardware I'm using here is basically Arduino Uno, LEDs, potentiometer, motor, power supply, and I'm also using an NPN transistor. Uh, so this is how the circuit indicates. If it's safe, I'm using a blue LED actually, and red LED is to mark unsafe. So this is the circuit. Can I move on with the simulation?
Yes, please go on.
Yeah. So yeah. So is my screen visible?
Yes, it is visible.
Okay. So the circuit is basically from my circuit I used for last round. So
I'm
this
sorry
has
to interrupt, but can you please zoom in?
yeah.
Okay, thank you.
I'm sorry. The circuit is a little too big, so I'm sorry. Is it visible, sir?
Yes, it is.
Okay. So here, according to the problem statement, I'm using two potentiometers to simulate the input. and I'm using two LEDs to show the output. I mean, like, I'm using LEDs to indicate, and this part, which is like the motor controller, is from a previous round, and so here we have a potentiometer to change the RPM of the motor with an IC555, and the code is basically, so I'm getting the values, initializing everything, and I've set the threshold as 600, and yeah, so the main part of this code is the if statement. So if it's unsafe, I've used this to compare. If CO2 level is greater than threshold, or if parts level is greater than threshold, it will consider it as unsafe. So bool unsafe becomes true, and if unsafe is true, this circuit triggers the warning. So we'll go with the simulation. So as you can see, the potentiometer is at 0. So the CO2 level and particles level is in 0. If I increase a potentiometer, right now I'm tinkering with a CO2 potentiometer, it like blows up, and here we can see that the RPM of motor, this is the maximum RPM right now, and so we can see that the motor is working. This is the ventilator, and if we go back to normal, then the motor stops. If it's the same with the particle levels, so on any combination it works the same, because we are using OR gate. Other than this, for future improvements, I can definitely connect this with an ESP32 or a Node MCU instead of an Arduino, and we could use that to like add IoT and like add it to a smart network or of other devices, so that like we could make a smart school system. So this is basically it, sir. And I'm using a separate power source for the fan, like, because it's possible. Sir?
Okay, Kunal.
Yeah.
What is the basic difference between Arduino Uno and ESP32?
So ESP32 has a 32-bit processor, microprocessor, microcontroller, and other than that, we have connectivity features such as Bluetooth and Wi-Fi. So we can use it for like communications, which we have to add a Wi-Fi module in Arduino, and it's really slow.
And if you have given three choices, Arduino Uno, ESP32, and Raspberry, which one you are going to use?
So for a IoT system, Raspberry Pi would be the ideal choice, but I am inclined towards ESP32 because of the versatility of the board. Yeah, so I'd pick a combination of Raspberry Pi and ESP32, so that I could make a home station with the Raspberry Pi, and I'd make small devices with the ESP32 and make it communicate with the Raspberry Pi. The Raspberry Pi would be the master, and these would be the slaves.
Thank you.
Yeah. Any other questions, sir? Can I leave, sir?
Hello, Kural.
Yeah, yes, sir.
Tell me the changes you will do in this circuit when it will be used in real life.
So
Like,
obviously, I'd replace the potentiometers with sensors.
Okay.
We have a lot of sensors to monitor air quality, so I'd be replacing it with this. And if possible, I'd like add a purification system with this, so that we could, instead of countermeasures of a ventilation fan, I could add a purification system and monitor the output of the purification system as well. So we could also know the efficiency of the purification system. And I would definitely include IoT so that like we could maintain records and monitor this when we are not in the space.
Okay.
And I would also like to include smart features like, if possible, I would like to have the feature of altering whatever air parameter I have, so that if the real air quality is kind of deprived in oxygen or some other thing, I could change it. And one more thing I would add is a perfume, so that the classroom smells nice, which is like a personal thing.
Okay.
Yes, sir.
Okay. Thank you, Kural.
Thank you, sir.
Okay, thank you, Kural. Next is Rohan. You can go ahead.
Hello, am I audible?
Yeah, you are.
Good evening, judges. My name is Rohan Barnwal, currently pursuing bachelor's from IIT Madras in Electronic System. Give me a moment. Let me just share my screen. Is it visible, Arushi?
Yes, it is.
Okay, so my problem statement was the smart classroom energy optimizer, and I have choose same as name of my project. So the aim is simple but powerful to make classrooms sustainable based on the occupancy and daylight. So energy saving is required because it helps reduce the electricity bills and saves money. It lowers the demand for power plants, which cuts down the air pollution and greenhouse gases. And it also conserves the natural resources like coal, oil, and gas for the future generations. Most importantly, it protects the environment and helps us to fight with the climate change. So for this project, I have mainly used these components, LEDs. So the LED represent the main light of the classroom, and of course the fan and the projector. Apart from that, I have used Arduino as the main brain for this project. Then I have used the light dependent resistor LDR for the daylight monitoring. Then I have used the I2C LCD to display the student count and messages. And of course, a toggle switch for the priority mode on and off. Now I would like to show you the circuit and of course project in working. So let me just share it. Give me a moment, please. Wait a minute. Is it visible, Arushi?
Yes, yes.
Okay. So here is my circuit. Here I have my Arduino board, which is Arduino Uno. Here is my LDR. And here are my three LEDs. So basically this white LED is based, its brightness based on this LDR. And these two LEDs, this orange and blue, represents the fan and the projector of the classroom. This is the slide switch which I have used for the prior mode, and this is the PIR sensor that will count the student and showcase over here in the I2C display. So let me just start my simulation. So it is showing the student count as 0. That means no one has entered. So if I move it, so it says welcome to school. Now it says student count is 1, and we can see all the lights and fans and projector are on, and the lights brightness is depending upon the brightness on the LDR. As you can see, if I move it ahead towards the bright, you can see it is going a bit dim, as you can see. So we can change it, like we can make the student count to 2. So I have set it to 4, like the main. Basically, this system works in 3 main steps. First is the occupancy counting. The PIR sensor counts the student entering, and the LCD welcomes the class at the count 1 and shows all the student at here at when the count becomes 4. So wait a minute. So as you can see, it says all the students are here now, and you can see it's all working now. If I change it, you can see the student count becomes 3. So basically, I have taken a threshold that there are 4 students, and after, if the sensor detects the any gesture or kind of human presence, so it will count that one is leaving the room. So if I do it one more time, again, and one more time, wait a minute. Yeah, and you can see as the student count becomes 0, all the lights and fans and projector turned off. Okay, so if I turn it on, this switch, and you can see the LCD says priority mode on, and all the lights and projector turns on. And with this smart classroom optimizer, we are not just saving electricity, but also teaching the student the importance of sustainability and a smart technology in everyday life. So I hope, judges, you will like this project. So that's all from my side. Thank you. Any questions? Am I audible? Wait a minute.
Yeah, you are.
Hello,
Any questions?
hello, Rohan.
Yeah, hello, sir.
Wonderful presentation. Um, can you add some feature regarding the attendance kind of thing? Like if you
Yeah,
want
sir,
to,
we can use RFID module for the attendance thing. With the RFID tags, we can have the different RFID tags to each and every student, which will help in logging the data of the students. We can also add a SD card module that can log the data of every day of the student that are present or absent.
okay.
And apart from that, for future enhancement, in this we can also add some kind of temperature sensor that will also help in controlling the fan speed and all for different weathers and climates.
Okay.
Rohan, I
Yes,
have
sir.
a question. How much important is the role of actuators in IoT? Means the role of sensor is very important. So how much important is the role of actuators?
Sir, can you please repeat that? Actually, I wasn't
The
able to listen.
role of actuators is of importance in IoT. So you rate how much the role of actuators are very important in IoT. As far as sensors, we are working on so many sensors
Yes, sir.
in the project. So the output depends on the actuators. So the which type of actuators you are going to use in your project if you get a chance to put it in a classroom.
Sir, for this project, of course, actuator like a smart for heat based fan that I have just said for in my future enhancement, that I can use this HVAC based system, based on the temperature we can control the fan speed or something like that in the classroom for the uh, better health of the students, of course.
Oh, thank you. Thank you.
Okay, thank you, Rohan.
Thank you.
So now Abhay.
Hello.
Yeah.
Is my screen visible right now?
Not yet. Yeah. Yes, it's visible now. You can start.
Is it in the presentation mode or the speaker mode? Which one are you seeing right now?
Speaker mode.
What about now?
Yeah, it's good.
Okay, so the problem statement I've chosen is an implantable glucose monitor with wireless alert. Another person presented this already before. We were told that two people could choose the same problem statement. So yeah, this was the problem statement that was given to me. That is, we need the safety monitoring of a diabetic patient with a low power design and having IoT features. So since we don't have glucometers or glucose sensing modules in the simulation tools, we were told to use a potentiometer acting as a glucose sensor. So the potentiometer readings will be, the glucose sensor readings will be simulated by the potentiometer readings. So yeah, this is the problem statement. And the challenge identified was that the diabetic patients require constant vigilance. That is, their blood sugar levels can spike randomly throughout the day. So hypoglycemia or hyperglycemia, high sugar or low blood sugar, can be very dangerous to diabetic people. That is, in some cases, it can even prove fatal. So the goal is to create a standalone, reliable, and low-power monitoring system that provides immediate localized alerts. That is, the patient or their immediate family members have to be alerted spontaneously in case of a blood sugar spike or fall. So the solution I've come up with is currently a prototype for an implantable glucose monitor. That is, I want it to be wearable by the patient, such that it alerts the patient as well as their immediate family. So, low power design was a constraint in the problem statement itself. So, we have incorporated that using an ESP32. So, this is the solution that I've come up with, and this is the circuit diagram. And moving on to the system architecture, I have chosen an ESP32 microcontroller that processes the data and the potentiometer to simulate the glucose sensor. And for the output or alerts, we have an RGB LED, a piezoelectric buzzer, and OLED display for reading the live glucose levels of the patient. So this is the process that the glucose monitoring sensor will undergo. So the device wakes up from the low power sleep mode. It reads the potentiometer or glucose sensor value. It checks whether the value is within the threshold. And threshold, if the value is above the threshold or below the threshold, that is above the above or below the safe glucose levels, then it will send an alert to the immediate family as well as the local buzzer and LEDs. So after every period of time, which is customizable in the code, it will go back to sleep mode to conserve battery power. So moving on to the simulation. So I have simulated it on Workui for now because Tinkercad does not have an ESP32. So if I run the simulation, and I used a sliding potentiometer here. Right now, the glucose level is 88 milligram per deciliter. So the ESP32 gives out only and can read only analog values. That is, the potentiometer gives a value between 0 and 40-45. So what I've done here is the ADC value that I've read directly, I've mapped it to a minimum and a maximum glucose value. So since we're just simulating the glucose sensor reading, I've assumed that the minimum glucose value will be 10 mg per dl and maximum value would be 600 mg per dl. So mapping these ADC values to the corresponding glucose value. This can be in case we are using an actual glucose sensor, we can just calibrate the sensor and do the mapping accordingly. So once we have that map, we initialize the OLED, and then if the glucose level is too low, say it's 10 mg per dl, right? So currently this is in the sleep mode. So currently for simulation purpose, I've set the time to sleep as 10 seconds. So after every 10 seconds, it will read the sensor value. So 10 seconds have completed and the ESP32 is back from the sleep mode and it has read the low blood sugar value and it has alert and it has sent a low level alert and the LED has been changed to red. Now say we were to increase the value. So after each 10 seconds only, it will read the value right now. So we'll just wait. This was the previous reading of low. And now we have a high level alert represented by the magenta. Workui does not give a visual indicator for buzzer, so that's missing right now. Now moving back to the PPT. Like we saw right now, we have a low level alert, a safe state that is between 70 and 180 mg per TL, and then the high level alert. So yeah, that's all. And since this was made in a very short time, I actually wanted to do the hardware, but my potentiometer right now is busted and I don't have Wi-Fi module right now. So future work that could be done on this is real sensor integration. That's obviously replace the potentiometer with a glucose sensor. And since we want it to be wearable, we have to miniaturize it. That is, the ESP32 is pretty big. So a smaller microcontroller like the Attain85 RP2040 would be optimal. And since we have an ESP32, wireless data transmission is possible. So we could have like a central Wi-Fi access point web server hosted that shows the live glucose levels. And since we are using a centralized web server, maybe we could also connect it to some application like Blink IoT, such that gives live notifications to their phones when the blood sugar level changes. So yeah, that's all. Any questions?
So, do you have any questions, sir?
Hello, Abhay.
Hello.
Great presentation.
Thank you.
How will it be miniaturized to a level that normal people can use? Because an ESP2 sensor is a little big.
Yeah, ESP32 is pretty big. There is this sensor called the Attain85. I'll just show you how small it is. It's just a very small board. So this is what they usually use in the wearable electronics right now, the smaller Fitbit bands and all. So if we could get one of this, we can make it into a wearable band or something like that with a lithium polymer battery, such that it's lightweight and compact. And the reason why I chose ESP32 right now is over the Arduino is firstly the wireless communication capabilities, and the Arduino Uno has an 8-bit ADC, while the ESP32 has a 12-bit ADC, so its resolution is higher for reading the analog input.
As I can see in the code, you have chose the glucose max level as 600.
Yeah, these are just arbitrary values. Here we don't have an actual glucose sensor, right? We are simulating it with a potentiometer. So we can only read the analog value between 0 and 4095 with a potentiometer on ESP32. So just to make it more readable, I just mapped it to a value of 10 and 600, just assuming the minimum and maximum values that human can have. Just an assumption.
And also you told in the presentation that whenever the high alert is there, the information will be sent to the family members.
Yeah.
So how will be they going to receive this data? Is it on the phone in form of message or anything like
There
that?
is this device, there is this platform called Blink. I actually wanted to do this with hardware right now, but yeah, time constraints. See, we can configure the app such as, wait, I'll show you. I'll pop up my IDE here. Okay, never mind. So inside this Blink app, once you create a template, it will give you a template code which you can add inside your ESP32's code. That is, the code that Blink gives, I'll add it in here, which will have my own authentication ID. So if I set this app on a family member's phone, I can make it so that every time this high alert is read, the ESP32 will have to be connected to a Wi-Fi initially, Wi-Fi with internet capability. Then once the high alert or low alert comes up, over Wi-Fi, it will send that alert message over to the Blink app, and they'll get the notification on their phones.
Okay. Anything you would like to add? Like if you want to integrate AI with this, how will you proceed?
Yeah, about AI, right now the code is such that we have to define the sleep time right now. So it's fixed at 10 seconds right now, say for 10 seconds. So there will be patients who are at higher risk and lower risk. So the higher risk patients would have to be monitored more frequently. So what we could do is, based on the patient's reading history, that is their previous blood sugar history, we can use an algorithm to continuously vary or calculate the sleep time of these of the microcontroller, such that both the battery life is also prioritized as well as the safety of the patient.
Good. Thank you, Abhay.
Thank you.
Okay, so now Dipanjan, you can go ahead.
Okay.
Yeah.
Does my skin is visible?
Yes, it is.
Okay. My project is about automated environment control. It is basically I have developed for the space habitats. So what it does in the basic form current now, it measures the oxygen and carbon dioxide level present in the air through various sensors, and also the temperature through a temperature sensor. And in the base of oxygen and carbon dioxide sensor, it opens a oxygen valve or a ventilation valve, so that the air quality always remains constant. And It uses a cooler and a heater to maintain the room temperature. So basically, this is it. It can be used in the space habitat environment, and in multiplanetary missions. It will be very useful. This is my working circuit prototype. So basically, there is no oxygen or CO2 gas meter sensor in the Thinkercad library. So I have used two potentiometer, and I can find one temperature sensor, which is this one. So basically, currently, this section, the CO2 level is low. Oh, sorry. First, let me simulate the thing. Okay. So currently my CO2 level is low and oxygen level is high. So both of my servos are currently stopped. So means both are closed. If there is a situation where the carbon dioxide level increases. Wait a minute.
Yeah, go ahead. Or is it done?
Actually, for some technical problem, it was working slightly time ahead. Uh,
Okay.
There was a temperature sensor also. So if I can show you that if it is like minus 11 degrees centigrade, the red LED indicates the heater. So the heater will turn on to heat the environment. And if it is exceeding a threshold, and the cooler will turn on, and it will cool the environment. So it is a basic life support system that I have built during this short period. uh, Basically this. Yes. This is my code. So I have nothing more to show because of my something is malfunctioning right now. Sir, I am
It's
done.
okay if anything is malfunctioning. You can just tell us manually how will.
Okay. So what would it happen? This is the control valve for the oxygen cylinder. So whenever the O2 level decreases of a certain threshold value, I have just randomly chosen it is about 400. It will open, and for the if the CO2 level increases up to a after a 6000 level, it will open a ventilation valve so that the CO2 can pass through the ventilation and make the room suitable for the habitation. Yes, sir, I am done.
Anything you would like to add?
Means in the future.
Yes.
Yes. I can do various things like in this simulation because of the resource. I have used a Arduino Uno, but in the space there are many things like space radiation, which can affect the circuits and cause troubles. So I would go for the STM32 and multiple of them, so that I can change means I can reliably switch the most accurate ones. Like if a STM32 malfunction, it will the other two will prioritize, and we will get the accurate sensing, so that the environment does not become worse. And there will be another system like I will add more sensor in the various corner of the room, or if there are multiple rooms, so that I can smartly monitor the oxygen and carbon dioxide level, also the temperature of every position. Then I will add some multiply some weight with the oxygen and carbon dioxide level, so that like for example, I have a section where the oxygen maintenance is not that much required, means low oxygen level is required on this position, and a position where normally human sleeps. So it would smartly choose that in which position we have to prioritize the oxygen level more. And overall the system will overall the system can sense if the overall oxygen level decreases, it will open oxygen valve in the all of the position. uh, there are I will use the PWN on the heater and cooler, so that it will not just blast in the full volume. It will gradually increase or decrease in, so that the temperature maintain more reliably. uh, and also the valves will be not in it just not open totally. It will depend on the current oxygen level, and open and close partially, so that it can maintain the O2 and CO2 level. And the system will then be connected to the main control board or the computer, so that we can monitor the current situation and oxygen CO2 temperature level, uh, uh, s- so that we can monitor that, and also can change slide values manually. And I will add a camera, so that based on the current position, like in which state are the humans sleeping, are they working very hard, they would need more oxygen. So I would add a AI system, so that it can monitor actually in real time, and changes the oxygen and carbon dioxide levels accordingly.
Okay. Thank
Oh,
you.
okay. Okay, Dipanjan.
Yes.
Uh, can you tell me some of the metal oxide semiconductor sensors which are used with Arduino boards? Name of
uh,
the sensors.
Metal oxide semiconductor sensors.
Yes, MOS sensors.
Uh, Actually, I don't have that much idea on that sensor level.
Uh, Apart from carbon monoxide, if any other gas is present there,
Yes, yes.
so which type of sensor you are going to use?
I would use some sensor which is used in the air quality monitor, but I am not exactly sure the sensor name. But I think they are available in the market.
Okay,
I
thank you.
can just do some research in it. Due to short time, I cannot do that kind of research.
Okay, thank you. Thank you.
Okay, Dipanjan. Now we have Lalit.
Am I audible?
Yeah, you are.
Okay, let me share the screen. Is my screen visible?
Yes,
Does
yes,
my
it is.
screen visible?
Yeah, yeah.
Yeah, so good evening to the respected judges and everyone. I am Lalit Sridatta, currently pursuing my diploma in data science from IIT Madras. And before going to this presentation, as kids, we often see empty classrooms while bulbs and fans are running, right? That's actually wastes a lot of electricity when we look at a broad spectrum level. When we look at a national level or a state level, there would be that's a huge amount of electricity that's usually goes into waste just because someone is not switched off the lights or the fans. So here I came up with a solution called Smart Classroom Energy Optimizer under the theme of IoT based energy conservation system. So here are the couple of problems that are there in the today's scenario. According to the research of Business Education for You, in the UK alone, 30% of energy in the schools is getting wasted during weekends just because someone forgot to turn off the lights and the air conditioners during the weekdays. And in India, it is 7 to 10% of the electricity that is wasted in the schools due to the inefficient practices. And the common sources of wastage include leaving fans and the lights, electronic devices are leaving these electronic devices on when they are not needed and not upgrading to the energy efficient solutions. So here is our objective. We are going to automate the lighting and the fan control in the room, which is going to reduce the energy wastage, which actually works based upon the occupancy and the daylight reduction. So and here is the brief introduction about my project goal. Here we are going to use two sensors, PIR sensor and the LDR sensor, which is also called photoresistor. Uh, this PIR sensor is used to detect the motion and this LDR sensor is used to detect the light. And we are going to use a priority slide switch, which I am going to explain in the next slide. And then as an output, we are going to control the lighting of the classroom and used to control the fan. And the main controller that I am using here for this prototype is Arduino Uno. And here is the working principle. When PIR sensor detects a motion, it turn on the light and the fan. And the LDR sensor, which is also known as photoresistor, detects the amount of light that present in the classroom. For suppose if the outer atmosphere is dark, certainly a classroom would be also dark. So that the bulbs, the lighting system in the classroom, that they need to glow very bright. When it is midday, when the entire environment is filled with the natural sunlight, when the entire environment is filled with the natural sunlight, we don't need the bulb to glow that bright, right? So that's how the PIR sensor and the LDR sensor gonna work, and they also gonna turn on the fans. When motion is not detected for more than 30 seconds, automatically the fan and the lights gonna off. And here is the priority mode that I said. When the priority mode is on, regardless of the PIR sensor and the LDR sensor, the entire lighting and the air conditioning systems of the classroom will work without depending upon the PIR sensor or the LED sensor. And here is the basic circuit diagram. Here are the components that I mentioned. This is the PI This is the photoresistor PIR sensor LED slide switch and the servo motor, which actually represents the entire air conditioning systems or the fans in the classroom, and this LED represents all the lighting systems in the classroom. And these are the simulation results. When no motion is detected, LED is turned off and the fan is on. When the fan is in off, when the motion is detected, LED turns on and the fan or else the air conditioning system is on. I would like to take you to the prototype level to my circuit, and here is the circuit. Let me just simulate the entire scenario here. So yeah, as you can see, currently no motion is detected. The LED is off. The LED is off, and the motor, the fan, that is also off. When the motion is detected, you can see the LED is on, and the motor is also on. Motor is on. It represents the lighting system is working. Here, for the code purpose, I set the maximum threshold to 5 seconds. I mean, for up to 5 seconds, if no motion is detected, they are going to turn off. And here is the priority switch that I said earlier. When this is on, regardless of PIR input or the LER input, the bulb will glow with full brightness, and the fan will, and the air conditioning system will work with the full brightness. So this is my presentation, and I would like to tell you about my thoughts. Tell you about I'm asking you for any questions on this.
Okay, tell me, what is the role of breadboard in a Tinkercad circuit simulation?
Well, sir, this breadboard is used to connect all the components in the Tinkercad simulation, and we can also use the breadboard to assemble the components. Sir.
So, is the all components are soldered or solderless in this?
In the real life, they should be soldered, but here it is not soldered. So, as this is just a virtual simulation, they need not to be soldered.
Okay. One more question: why we use servo motor in a smart classroom project which you have done here? So, what is the role of a servo motor?
Well, servo motor here represents the as it represents the fans or else the air conditioning system of the classroom. So we can replace the servo motor with a bulb. It basically acts as an indicator, just showing that air conditioning system works when the motion is detected. It is not working when the motion is not detected.
Thank you.
Thank you, sir.
What about penetration? Lalit,
Thank you, sir.
is my voice clear?
Yes, sir. Your voice is clear.
So this is the second time I think I am seeing this kind of project in this evening. So till now I have not got any kind of innovation in this smart classroom thing. So if you have got more time, would you have added something related to like something innovative in this project? Because these
Well,
systems
I would like to
are
add.
already present in offices and some classrooms also.
Yes, sir. If I got a more time, I would like to add a buzzer, which actually indicates the priority mode, whether it's on or off. And I would like to add some motors, which actually makes the windows open or close by itself, and an attendance portal thing, which actually works on biometrics. We can place a fingerprint sensor that takes the reading and marks the attendance, and
Okay,
also a temperature sensor that reads the room's temperature, and based on that the air conditioning system works.
okay. Should have added these things also.
Yes, sir, but due to the time constraints and limited availability of components in the Tinkercad, I didn't add this, and I would like to replace the with the ESP32, so that we can also uh,
access this remotely.
Okay. Thank you, Lalit.
Thank you, sir, and thank you to the team Circuitrix for giving me this wonderful opportunity.
Thank you, Lalit. So next is Lisa. If it's and also if it's possible for everyone, like who all are presenting, to turn on their camera, then they can. Lisa. Is she there? Srinath?
Yeah, she's there, I guess. One second.
I guess no.
I think she left the meeting.
Okay, Thanuj, you can take over now.
Hello.
Yeah.
Yeah. First of all, it's a very honor to be present in this event, and thank you for giving this me opportunity. Yeah, coming to the problem statement. So let me introduce myself first. So I'm Mahinder Tanuju, currently pursuing IITM BS. Currently I'm in a diploma stage. So coming to my problem statement, the thing is, in the schools we can have the first priority is the students. I mean, they are going to be the future for our nation and for the new innovations. So we have to also educate them, but also we have to see the safety of the students. So coming to my problem statements, it is an air quality monitoring IoT device for the schools, and we can also improve. In this, we are going to see the brief to the problem statements and required hardware, hardware and circuit simulation and final improvements for this IoT device, which I have made. So the problem statement is the same. One of our not teammate. Also, the same person also had already presented this, but I have made this optimized, and I have some new things to say. So first of all, we are going to use the hard coming to the hardware requirements. We are going to use Arduino Uno and main basic items such as breadboard, jumper wires, and potentiometers. Potentiometers, because we don't have uh, the devices to monitor the air quality, I mean carbon dioxide level and particulate monitoring. So currently I'm using a potentiometer to denote this, and LEDs for indication, resistors for controlling the current, DC fan, I mean the ventilation, and the power supply. Coming to the simulation, so here is the Arduino, and I have also connected. These are the potentiometers. This potentiometer is for carbon dioxide level, and this is for particulate matter level. So first of all, let me explain the whole setup. So these are the inputs, and the motor and LEDs are the outputs. So when coming to the carbon dioxide, when the carbon dioxide level increases, there will be a difference potential. I mean, this is designed in such a way that the potential differences changes. The motor ons and LEDs indicates the same for the other potentiometer. These we can change by implementing the real hardware's equipments. Coming to the carbon dioxide level, so when the carbon dioxide level increases, I mean the potential drop is very small. So this goes to the potential drop goes to the input A0, which is an analog input pin, and the same for the particulate matter
Also, coming to the outputs, we have a motor and LEDs for indication. So the red one is high of carbon dioxide, and the lower LEDs are for particulate matter indication. The red is a high amount of carbon dioxide level, and this is the green is for safe level, less than the threshold. So this is the motor which runs. Same for the particulate matter indication. The red LEDs glows when there is less potential difference between this. I also used an AND gate, which means here we get almost the 5 volt, 5 or 4.5 and above. So this is connected to an OR gate, and if this is on, then this is off. If it is 5 high, this is low, and when this is low, it is high. This is NOT gate, which inverts the voltage level. So coming to the both, I mean, coming to the, if the carbon dioxide level also increases and the particulate matter also increases, there will be two LEDs which will be glown, and we can speed the motor, I mean, which is a ventilator. Let's go to the simulation part. So the same setup, let's simulate it. So as it is low, which means potential difference is low, there will be the signal will going to the A0 pin, and here the green level indicates we are in the safe level. So when I increase the potential, when I increase the potential, the LEDs glows. I have kept almost 50% or 45% of it so that it can on. The threshold is 45% than the zero level, high level. So here it is, when I increase the when the potential is high, the LED goes on, which means the motor is also going on. Coming to the particulate level, only particulate matter also increases. The motor spins up with a high speed, and when we integrate both of these, the motor gets on, and we get the both LEDs high, which means the carbon dioxide level is high and particulate matter content is high. So coming to the improvements of this IoT, this device setup. So here, as we increase the carbon dioxide level, the RPM is constant. I mean, let's say the carbon dioxide level is little bit higher than the threshold. We can increase the RPM to not this percent. We can increase it proportionally to the voltage difference, as it is at a constant potential. I mean, constant rotation speed. So we can improve it by decreasing the power of this whole device setup. And the same for the part, this code. Here also the serial monitor setup, as let's say both are high, the PWM, the CO2 and particulate matter level is high, so the fan is turning on. So this is my setup. And coming to more improvements to this device, so we can replace the Arduino with directly, I mean, for the less power consumption and for increasing its scale, so we can use direct for comparing these potential differences. I mean, which means, let's say, CO2 potentiometer, the potential difference, we can give it to a op-amp, which acts as a comparator, and both these we can use directly to the comparator, and we can implement in this without using the Arduino. So this is it from my side. Thank you. Any queries?
Okay, tell me, in Tinkercad code editor, which function is used to set up pin as either an input or an output?
So pin mode is used for input or output in the
And
setup.
And for PWM output, which pin you have used on Arduino Uno board?
So I have, so let me show the presentation. Sorry, my screen. Yeah. So I have used it. I mean, we can use it normal digital pin or these which are showing a approximate symbol. These are the PWM pins, and the direct one are digital pins, which means high or low at the whole clock cycle. I mean, not a clock cycle. It will be a constant voltage. Let's say if this number 3 pin is a PWM pin, which means pulse width modulation. I mean, it acts as a clock. I mean, 50% of the time it is on and 50% of the time it is off, so that we can decrease the power consumption. I mean, so that's it.
Thank you.
Anything?
Okay, Tanuj, can you re-explain the optimization in power consumption?
So let me explain. Yeah. Coming to the power optimization, so I have used a digital pin here, which means here it is a digital pin. Let's say we have, coming to the Arduino part, I'm explaining with the, I mean, the digital pins which I have used can be replaced with the PWM pins, which means it will be acting high in the 50% of its duty cycle and 50% low, because the clock speed is very high, so that the LEDs is turning on. The same will act as our room LED, room light source. They are also AC sources, so the same will act. Coming to the, without using, I mean, replacing the Arduino with direct hardware equipments, let's say. So here I have used to compare this, the Arduino will do the whole part, but we can use a comparator, I mean op amp as a comparator, so that we can scale up it in a very, I mean, we can make it compatible and scaling it. Did you guys got it?
Okay. Thank you, Tanuj.
Yeah, thank you very much.
Okay, thank you, Tanuj. Now, Jaswita. Jaswita, are you there?
So, good evening, everyone. I am Jashwita Kumar. I hope I will present my screen. I'm presenting my project titled Smart Neuroprosthetic Control Interface. This belongs to the domain of assistive technology and neural interfaces. The main idea is to control prosthetic hand movement using simulated muscle activity. This was the problem statement I was given. The prosthetic hand should be natural and intuitive to use. In real systems, muscle signals are measured using EMG sensors, which are the electromyography, which uses the electromyography signals, which are derived from the muscle activity. And in this project, I used a potentiometer to simulate those signals. The goal is to control a servo motor representing a prosthetic hand using Arduino. So in the core idea, the potentiometer acts like a muscle signal generator. Arduino reads the input, maps it to an angle, and moves the servo motor accordingly. And the servo behaves like a prosthetic hand, hands opening and closing. An LED shows the strength of grip, and a buzzer gives a short beep after the hand stops moving. And when we talk about prosthetic control, There are three types of prosthetic control, which are body-powered prosthetics, myoelectric prosthetics, and also the bionic prosthetics. In body-powered prosthetics, uh, that uses cables and harnesses controlled by the user's body movement. In myoelectric prosthetics, those are the thing which uses the electrical signals from muscles using the EMG for more natural control. And in bionic prosthetics, which are the advanced versions with sensors, AI, and even brain computer interfaces. Here I have used a potentiometer since we don't have EMG sensor in Tinkercad. And these are the main components. Arduino Uno is the main controller, a potentiometer as the input, a servo motor as the prosthetic hand, an LED as a visual feedback, and a buzzer as an auditory feedback system. So this is the block diagram. This diagram shows the flow of system. The potentiometer provides the input, the Arduino processes the value, and outputs are the servo movement, LED brightness, and a single buzzer tone when the hand stops. So the control logic is very simple. First, the potentiometer reads the value from 0 to 1023, which is 1023. And when we talk about that value, the number 1023 comes from the Arduino's analog to digital converter, which is the ADC. The Arduino Uno has a 10-bit ADC. That means it converts an analog voltage from 0 volt to 5 volt into a digital number between 0 to 1023.
Jaswita, just a second. Sorry for disturbing. Your slide is not changing.
Yeah, I have changed my slide now. Is it visible?
It is visible, but change it according to what are you speaking, okay? So that judges are
Yeah,
comfortable
I
reading.
just told this as an insight. I didn't mention this in the
Okay,
slide
that's
because
okay.
okay.
Yeah, that's
And the value 0 corresponds to 0 volt and 1023 corresponds to the 5 volt. And when we talk about the circuit diagram, the potentiometer is connected to A0, the servo to pin D9, and the LED to pin D13, and the buzzer to pin D3, which I'll be showing in my prototype. So this is the working demonstration and concept value. In operation, rotating the potentiometer simulates muscle contraction. The servo moves smoothly to open and close the prosthetic hand. The LED brightness increases or decreases with the grip force. And every time the servo stops, the buzzer gives a clean short beep. And the concept value of this project is that it demonstrates how user input can mimic neuro signals. Even with simple electronics, we can simulate a prosthetic hand control. It is an intuitive and low cost proof of concept. This project is simple and low cost and also demonstrates proportional control. It provides both visual feedback through the LED and auditory feedback through the buzzer, and it serves as a foundation for advanced prosthetic systems. So in the future, the potential...
Jaswita,
Yes, sir.
Jaswita, your slide is not changing. Can you fix that?
Is it visible now?
No. It's actually in the first slide only. We can see the first slide only. Can you change?
Okay. Is it
Yeah,
visible now,
now
sir?
it's changing. Yeah.
So these were the previous slides. I hope. So is it
Uh,
visible now?
yes, it's visible now.
Yeah, in the future, the potentiometer can be replaced with real EMG sensors, and multiple servos can be used for finger level control. Wireless communication like Bluetooth can be added for feedback, and also machine learning can help recognize gestures for advanced control. So to conclude, this project shows how Arduino can simulate a prosthetic hand using muscle signals. The potentiometer controls the servo smoothly, the LED indicates the strength, and the buzzer confirms movement after the servo stops. So can I share my circuit?
Yes, please go on.
So this is my circuit. And this is what I mentioned. When we change the potentiometer value, the servo motor moves according to the mapped distance, and the buzzer buzz after the servo motor stops. And also the LED blinks accordingly, as we can see here. And when we talk about the code, the servo.h library is included, and a servo object is created to control the motor. Potentiometer is assigned. These are the pin assignments, and the variables are used to track the servo angle, movement time, and whether the buzzer has beeped. And also the setup function attaches servo to pin, sets LED and buzzer as output, and starts serial communication. The potentiometer value is read using analog read and mapped to 0 to 180 degrees for servo control. Servo rotates accordingly to input, simulating a prosthetic hand's movement. And the when we talk about the LED feedback, the potentiometer value is also mapped to 0 to 255, controlling LED brightness as a visual feedback. If the servo angle changes, a timer starts, making the servo as moving. This process repeats continuously, ensuring a real-time control. So this was my project. Thank you for this opportunity.
Javitha, I have a question. Which
Yes, sir.
component you have used to detect the bending of a finger? Because it acts as a main input sensor for a prosthetic hand. So which component you have used to detect the bending of a finger?
Sir, as I have mentioned, I didn't have much time. Like in real prosthetics, each finger joint is controlled by a small motor or actuator. We haven't done anything like that here. The servo motor just represents the prosthetic hand or finger. When the potentiometer value increases, the servo, we can also take the servo motor as the bending of the finger. Like if it moves this side, like to the right, we can take it as the it is bending towards. We haven't mentioned anything properly like that.
Can you name the actual sensor which is used in actual projects for prosthetic hands? Have you heard about flex sensor?
Sir,
Flex sensor. Have you heard about flex sensors?
You are not audible, sir. Could you please repeat that again?
Have you heard about flex sensors?
Yes, sir. Like which measures the magnetic flex, like the strength and direction of the field. I'm not clear about that.
Okay. Thank you.
Hello?
Yeah, okay, Jaswita. Thank you. Now, Sayantan, you can go ahead. Sayantan, is he there, Srinath? Yeah, go ahead.
audible? Okay, then I'm starting my screen share.
Yeah.
I hope my screen is visible.
Yes, it is.
Okay. So, good evening, everyone. My name is Shantan Dey, and today I'll be presenting the problem 8 statement, which was the wearable health monitor designing. So, this wearable health monitor is a compact body monitor which will study the body temperature and the response of the heart rate. If it exceeds a certain threshold, then it will give an alarm as an alert. So here we cannot simulate the heart rates as a heart sensor. So we are using a potentiometer as the heart rate sensor. It will simulate the heart rate as it changes from the analog values. It will map the values to the changing, and it will tell from 60 BPM to 180 BPM. The temperature sensor, we are using the NTC thermistor, which will read the temperature of the person. So the emergency logic is the threshold, once it is breached, it will trigger a buzzer and an RGB LED. For each type of alert, there is a different kind of color in the RGB LED. So I have fixed the heart rate threshold at 120 BPM, and the temperature threshold I have fixed at 38 degrees Celsius. So this is the circuit which I've made. I've used an Arduino Nano for this circuit. The potentiometer is reading the is inputting the analog values, and the NTC thermistor is also inputting the analog values to two respective inputs, A0 and A1 of the Arduino Nano. The buzzer is connected to digital pin 9, and it will sound when the threshold is reached. The RGB LEDs are connected to the different R, G, and B wires of the circuit. So I'll be showing the circuit now. I'll be completing the PowerPoint first. So I have made it a low power design since it's a remote application. So using Arduino Nano, I have made it low power consumption and compact accommodation useful. And I have also made a sleep delay, which can be, so it does not read all the time. I have made around 5 seconds delay. So it sleeps for 5 seconds and then reads the values and again goes back to sleep. So the benefits of this circuit will be that it can read the body temperature and heart rate of a person efficiently. Using the Arduino Nano, it is low power consumption, so it can be used anywhere. Also, the Arduino Nano consumes minimum space for compact applications, and also makes people more conscious about their health. So now I'll be showing the circuit. So this is a circuit I have made. I've already explained the thermistor and the potentiometer parts. I have fixed the heart rate pin to A0 and temperature pin to A1. The thresholds of the heart rate are 120 and temperature threshold is 38. So the Arduino Nano will map the heart rate from the potentiometer to 60 to 180, and it will map the NT thermistor readings, analog readings, to 20 degrees to 40 degrees. And if it is greater than a threshold, then it will light up the RGB to red. Else, if the temperature threshold is reached, then it will become blue. Otherwise, it will be green. And it will wait 5 seconds before the next reading. And after alert, it will digital write all low to the pins and return of the buzzer. So on simulation, so right now it's in pink, it's glowing pink. I don't know why, because so it's now at 36 degree and there is no buzzer sound coming. So when I increase the temperature to 30, 40 around, After 5 seconds, it reads the values and the buzzer is sounding. And the RGB LED has changed its color. If I decrease the temperature, and now it will return back to the original color after 5 seconds. It reads and it's at the normal color. Now if I increase the heart rate sensor, which is the potentiometer, I make it around, and now the heart rate has exceeded the threshold. So it is now lighting up a different color, and the buzzer is also sounding. So this is my circuit.
Okay, so and then tell me about the optimizations you have done in the circuit.
Hello, guys.
Hello, am I audible?
Yes, sir, you are audible. Santhan?
Santhan, tell me about the optimizations you have done in this circuit.
So in the optimization part, I have not used the Arduino Uno for this because it's yes, you're audible, sir. So am I audible?
Yes, you're audible.
Okay, Santhan.
Hello?
Santhan, am I audible? Santhan? Santhan, can you hear me?
Just let me change my device. Okay, I'm audible. Okay. So for the optimization part, yes, sir. Yes, sir, you're audible, sir.
Which microcontroller is used on Arduino Nano board?
Yes, sir.
Which microcontroller is used on Arduino Nano board?
I think there is some lag between Santhan and us. You can read what
Yeah.
you want.
Okay, so we'll continue with the next. Swadesh. Swadesh, are you there?
Sir, am I audible now?
Yes, you're audible.
Okay, sir. So I'm sharing the screen once again. So you can see my screen now.
Yes, it is visible.
Okay, sir. So you were asking some questions.
Yes, what are the optimizations you have done in this circuit?
So for the optimization part, I have used the Arduino Nano instead of the Arduino Uno because it uses low power and it is more compact. And the other optimization which could have been done, instead the NTC thermistor could have made it a little bit smaller, and the RGB LED could have been more optimized.
Okay.
Okay, thank you, Sandra.
Thank you. Thank you.
So I guess we are done with everyone.
No, hello.
Rupak.
Yeah.
Okay. Yeah, go ahead.
Okay.
Not there. When we called you. Yeah, you can go ahead now.
Am I audible?
Yes, you are audible.
Hello.
Yes, yes, you are. Go ahead.
Um, Good evening, batchmates, coordinator, and judges. I am Rupak Kumar, and I am going to present wearable health monitor. Okay. This is the content, reduction and objective components use circuit diagram, working principle, Arduino code and simulation, application and benefit, and conclusion and future discovery. So what is wearable health monitor? Okay, this is the first question when we talk about the wearable health monitor. What is? So basically, this is the something we can wear and monitoring our health, like pulse, speed, or anything which runs out, which gives our body as output. And why are such devices important? Because uh, right now I'm suffering from fever. Suppose I right now suffering from fever, but I haven't thermometer or something, so I can see my body temperature. That's why it's very important. This is the objective, right? In this project, this type of health monitor, health heart rate, body temperature. This is the is we can measure with the help of circuit or sensor. Next component, we use Arduino Uno potentiometer for heart rate temperature sensor for body temperature, RGB LED alert in the form of LED light, buzzer if any emergency, if our body temperature are above than 120 or sorry, body temperature above than 38 degrees Celsius and our heart rate above 120 or less than it helps a register and breadboard and jumper wires. This is the circuit diagram. This is a snapshot of my Tinkercad. Very huge. This is the use of RGB LED, ultrasonic sensor, temperature sensor, Arduino Uno, buzzer, potentiometer. This is the working principle. So potentiometer is used to simulate heart rate by adding analog voltage. Okay, so this is analog voltage. How analog voltage works? So suppose in Arduino, there is a pin A1. Okay, and it has some formula like it's some formula which Arduino uh, um, Arduino calculate self by self. LM35 sensor. This is it's also connect to analog voltage, analog input in Arduino Uno. Okay. The LM35 sensor helps to like converting the body voltage to body voltage to our voltage into degree Celsius. Like as LM35 sensor has ideally 10 millivolt is equal to 1 degree Celsius. and this is the normal when normal condition. There is a green LED glows, and I will also simulate in the Tinkercad abnormal condition. If heart rate is greater than 120 and temperature is greater than 38 degrees Celsius. This is the basic coding, basic logic which is used in Arduino coding. Application and benefit: smartwatches fitness track, smartwatches which monitoring fitness tracking. I already told you. This is a low cost health monitoring system, and benefits: it's easy to implement, easy to making. If anyone wants to, then make it. And this is the conclusion. Uh, this is a successful design, and RGB LED and buzzer helps to monitoring our alert system. Alert means one above the 180 degree heart rate and 38-degree body sensor. If we connect Futurescope, we connect with Bluetooth and Wi-Fi, then it's also send us signal to our mobile phone. We can reach GM module. Thank you. Can I share Tinkercad? Hello.
Yes, please go on.
This is our whole circuit with the help of Arduino Uno, potentiometer, ultrasonic sensor, temperature sensor, RGB, and you use resistor for if more voltage supply, then our RGB will be damaged. That's why I use resistor. It's actually 220 ohm. If I less than, then it's huge current supply and maybe it's break. Or if I low, then its light is very dim. This is the code. If I start simulation, it takes input enter heart rate. Suppose I click 110 and 37. Then green light. This is the conditioning part. This is the heart rate high maximum this and minimum 50, and temperature high maximum 38 and minimum 36. Here the input text, or if I above 130, but my temperature is 7, then buzzer will and RGB right. Thank you, sir.
Yes, thank you, Rupak.
Is there any questions? sir. Hello.
Hello, Rupak.
Yes, sir.
Tell me about the toughest thing you faced in this circuit. What was the challenge in this problem for you?
Connecting to connect wires, sir. There's too messy. That's really challenging, and also sometimes yes, a putting register, because I forgot to put register on this when LED broke sometime when I simulate, then I realized, so I put the registers. And
Okay.
yes, sir. Yes, sir.
So sorry to interrupt. Actually, he's a data science student. He's not from electronics background. Okay.
Yeah, I am data science.
So yeah. So few students are also from data science, but they are interested to participate in this event.
Okay, if it is like that, he has done a very good job.
Yeah.
Thank you, sir.
And most of the participants are also from data science domain.
And also the other participants who are from data science domain are like have done a very good job if they presented and also simulated a circuit in such a uh, small amount of time.
Okay, Rupak,
Yes.
tell me, what is the name of the programming environment within Tinkercad which uses graphical blocks to create code?
Sorry,
Rupak,
sir, I can't understand. Can you again? I can't understand.
Okay. I repeat the question. Tell me the name of the programming environment within Tinkercad which uses graphical blocks to create the code.
Another like Tinkercad, another platform like Tinkercad.
No, in Tinkercad only. What is the name of the programming environment which changed the graphical blocks to create codes?
Okay. This is the Arduino, R3 code, C++ code. Okay, this helps to simulate this. This is the circuit.
Okay. Have you heard about Blockly in Tinkercad?
No, sir. No, sir.
Thank you.
Okay, thank you, Rupak.
Thank you. Thank you, sir. Thank you, coordinator.
Okay, so you can stop the screen share, and I guess we are done with every participant.
Sorry. Yeah.
Just give us 2 minutes to evaluate and decide the winners. Srinath, and so you can just.
I'm ready to present because of my network, so I disconnected.
Okay, so will you present now?
Yes, ma'am.
Please make it a bit quick because we are over time now.
Okay.
Okay, go ahead.
Is it better?
Yes, it is visible.
My project is renewable microgrid stabilizer, and this is the problem statement. And my introduction to this project is in today's era, we are want to depend on the renewable energy, but we know that solar energy and wind energy are not always constant because of the solar energy in daylight also depends on the cloud environment, and also the wind speed is not so constant. So according to the availability and the generation of the solar energy and wind energy, we need to I have made a microcontroller which control the stability and according to the load.
Suresh,
So
your screen is not visible.
now it is visible.
No, Sadesh, it's not. Yeah,
Yes,
yeah, it
yes.
is.
Not visible.
In this system, I have three different components. One is buffer variability. When the load the necessary of the load is high, then it's draw from the buffer and also from the source, and the integration component and the stability maintain the stability load out. Okay, this is the system component. So I have used Arduino Uno R3 and also use potentiometer to show the simulator here for wind energy and solar energy, and the buffer level using four LEDs, red, orange, yellow, and green. And I use some logic. Use the logic actually. So here the smart potentiometer block diagram. Thus, there is the solar input and wind input, and it's connected to the Arduino input, and it's reads the input and calculates and runs the algorithm, and also balance the storage and decide the load. According to this, it's shows at the output storage level, and also the status. How can is it available to handle the load or not? And also runs the source. So can I simulate? So
Yes, go ahead. Go ahead, Sadesh.
this is my circuit. I have used two potentiometers. One is for wind and one is for solar. So let's start. This is the code. So when I decrease the wind energy and the storage, so this and it shows the wind is 0, and here the LED indicates that the wind power generation is disabled, and when I decrease the solar energy, also the solar energy gets the yellow light also 0, and here also the solar energy will 0, and just it's running from the storage, also the buffer, and when I decrease all of this, the solar energy and wind energy, then it is drawing from the buffer system, and when it is the storage is 0, then it's indicate a rate. So the status of the RGB is such like that. When the buffer plus system is on the buffer plus the system is equal to load given, greater than equal to load given, then the RGB will show green light, and the renewable power plus loads is is less than greater than the load demand by 2. Means that the 50% of load demand greater than 50% of the load demand, it will show the YOLO, and if it's below this, then it will go for red. So I have some future scope. Okay. So future scope about that, I want to automate the washing mechanism of the solar panel. So I add the sensor with the Arduino to check the intensity, and also keep the according to the intensity. I also set a map like that, so that if the intensity is such that, then the solar output should be like that. If it is not coming from the solar energy, then it will start the washing mechanism, or also indicate the warning to the manufacture so that it can replace the damaged solar panel. Also, same for the wind machine, wind wing. If it is not working, then also give the message to the system so that it can be repaired. And also the AI integration to this Arduino setup. So I want to integrate the forecast algorithm system to the Arduino with the Raspberry Pi or the any cloud server based system, so that it will predict the availability of the load handling mechanism. So we can avoid the load shedding. So thank you for my presentation. Is there any questions?
Okay, thank you, Swadesh.
Wonderful presentation, Swadesh. I think this is one of the most innovative solutions I've seen in this evening, because this is a very small problem, but it has a greater impact when it comes to the practicability of solar panels, because the quality of absorption degrades when the dust is there on the panel. So, good job.
Sir, sorry for this. I think this is very fast for me. And I also indicate something on this project, just like that. If I think if the solar panel is damaged, then I should bypass this panel. Means that if the solar panel is connected in series, and at a particular level, if any of the solar panel is damaged, then if I connect the multi controller at this point, then it's also it will automatically trigger out that it is damaged. So I should bypass this, and in this way I can run the grid at the instantaneous time, so that at some time I can replace the damaged solar panel.
So you are saying that you will bypassing the panel when it is damaged or it is dirty.
It's when it is damaged, because when the solar panel is damaged, then it's a drawing the power from the grid, because it's like a behave like a resistance.
And also, have you calculated the amount of power it will require to clean that panel? Have you done the
Okay, no,
optimization?
sir, I have not so much time. If I
Okay, thank you, Sudesh.
Okay, thank you, Swadesh. Now just give us 2 minutes to evaluate. Until then, I would like my guest of the evening, if they want to say something about this event or anything to acknowledge us, then you can go ahead.
It's great to be there on this platform. Thank you for inviting me, and it's quite surprising to see the ideas which the budding engineers are providing here, and with the limited constraints of the tools as well as the time. So it's great to see how they are thinking and how innovative they are with their ideas. So it's a great experience for me today. So thanks for that.
Same here. Thank you for inviting me for this prestigious event, because what I was looking for was not the perfect solution, but it was a passion which you have in yourself. And also, I was surprised to see some data science student doing IoT and circuit things, because the future is not only limited to computer science and software development, but also the two fields will get merged in future. And all the best to your future endeavors, and keep thinking and keep doing these practical things apart from your studies, because it will really help you I'm saying this from my experience because I was also involved in these events in my college time, and it gives you an edge over others because theoretical knowledge is not uh, much useful when you come to work with an organization. And thank you so much, everyone.
Thank you, sir. It was great having you both. Srinath, can you take over it?
Okay. Hello everyone. I just want to appreciate everyone for participating in the Circuitrix event. So most of the DA students also excited to participate in this event. So at first we thought like no one can join this event, but we are really surprised for this. Like so we got a good response for round one and round two, and you guys performed very well in the final round. So and also the judges, and thank you so much for joining. So as I can see, everyone performed really very well in this. So just bit slight margin. So we are gonna announce the winners. So sir, I'm gonna mark the winners in the sheet. I think it's better to announce from your side. I can, but you are the judges, so it would be better if you guys announce it. So I'm gonna mark them in the sheet so that you can see them. So yeah, Arishi, can you do that or
Yeah, I'll do.
yeah?
So red one is the first one, the first
Or you
position.
can do one thing in the place of okay, do that. It's better to give the color code.
Second is yellow.
Yeah, and for the third person, you can give the green code.
Green, yeah. Okay, sir, now you can take over and announce the winners. Okay.
First of all, for me, everyone is a winner. Everyone who has participated is a winner to me. But with small margins, I would like to announce the winners. Though, uh, so the first person to win this contest is Akshay Ajit Rukade.
Congratulations, Akshay.
Congrats.
Second person is Abhay Krishnan AS.
Congratulations,
And the
Abhay.
third one is Mahendra Kar Thanuj. Congratulations to you guys and all the best for the future.
Thank you, sir, and congratulations, everyone. It was great having you both.
Thank you so much.
Thanks a lot for. Thanks a
Thank
lot.
you, sir. Thank you, everyone.
Thank you, sir.
And
And
yeah,
congrats.
and we are looking forward to join our future events which are conducted by
Yeah.
Jarvis Society.
We would
So
like you to
actually
join
in
our
our
future
society there is
events.
an electronics domain.
Okay. Sure, sure. We'd
We
love to be a part of your events in future
yeah,
also.
thank you so
Thank you
much.
so much.
Thank you, sir.
Okay.
Hello guys.
Congratulations, guys.
Congrats, guys.
It was really great
I
having
was
you
in
both. It was
shock.
really difficult announcing the winners.
Arushi, can you stop?
Yeah, I stop this streaming. Stop this streaming.
Yeah.
Yeah.
And also